시작해보자. 잠시만. 오케이. 이번에는 숙제 괜찮았어? 너무 어려웠어?
조금 어려운 거 있었는데 괜찮았어요.
조금 어려웠어?
네.
저번보다는 쉬웠지?
네.
다행이다. 잠시만. 오케이. 어디 보자. 그래핑을 했지 우리가. 맞아. 오케이. 첫 번째 문제부터 한번 해보자. It says a polynomial p has zeros when x equals 0, -1/6, and -3. What is the equation of p? What is p? 이거 예지가 시작해볼래? 이거 뭐 나왔어?
Is it parentheses x minus 0 parentheses x plus 1/6 parentheses another parentheses x plus 3?
You're okay. This is correct. There's nothing wrong about this, but usually we just write this as x. So we write it like this.
Oh,
We don't really need the x minus 0 because it's kind of redundant, right? It's unnecessary. X is going to give you the same answer, 0. So this is the way you would write it, but this is also right. Yeah.
okay.
Next question. Plot the zeros of the polynomial where p of x is x plus 2, 2x minus 3, and x minus 3. Where do you think the points would be? 하늘아, 이거 했어?
-2.
Okay, -2. -2 here.
And then I wasn't really sure, but would it be 3 on the y-axis? Oh wait, 2 on the y-axis.
2 on the y-axis. So here?
Oh wait. Is -2 on the y-axis.
-2 on the y-axis. So here?
Yes.
Okay.
And then +3 on the x-axis.
And +3 on the x-axis. Okay. So let's look at the middle one, right? It says we're given 2x minus 3. And wait, first, before that, let's think about how we get these solutions. We solve for these solutions by setting this equal to 0, right? And we use the 0 identity, which allows us to split all of these 3 things into x plus 2 equals 0, 2x minus 3 equals 0, and x minus 3 equals 0. And then this is how we solve. X equals -2. That's this point. Good job. X here is going to be 3/2 because 2x minus 3 equals 0. If we move 3 to the other side, 2x equals 3. Divide 2 by both sides. X is 3/2. And the final one, x equals 3, is correct. So the middle one, we just plot it as 2.5, which is right here. Since these are all solutions, they should all be on the x-axis. None of them should be on the y-axis. But other than that, good job. Okay, let's move on. our next problem. Was this section easy for you guys? Do you guys just want to skip it, or should we go over the rest? Nothing?
I think
Okay.
it was pretty simple, so, but
It was pretty simple.
not sure.
I think this is pretty simple too. Let's move on to zeros of polynomials with factoring. Our first question is P of x is going to be x squared minus 9 x squared plus x minus 2. 이건 민혁이가 해볼래?
이거 그 포인트 어디에 찍혔는지만 말하면 되죠.
맞아.
일단 첫 번째는 minus 3
So, minus 3, okay.
and minus 2
Minus 2,
and positive 1
positive 1,
and 3.
and 3. Okay, I think that's right. Everybody else got this, right?
Yeah.
Okay, let's move on. And let's do the second question too. P of x is given as 5x cubed minus 5x squared minus 10x. 이건 시우가 해보자.
저희 파트 이해가 잘 안 갔어요.
이해가 잘 안 갔어? 알았어. 그럼 이거 같이 해볼까? So, who can tell me the first step, what we should do when we're given this equation,
Find the greatest common factor.
right?
5x.
5x, nice job. So we find the greatest common factor because we want to factor, right? Factor this expression. And Sarlini said it's 5x. So we can take out a 5x from this equation, leaving x squared on the side, minus x, and minus 2. What's our next step?
Factor the x squared minus x
Right.
minus 2.
We factor this binomial. We can split it into two binomials. We factor this trinomial, sorry, it's a trinomial. X squared has to start with an x and an x. Negative 2 is going to be combined with negative 2 and 1, or 1 and negative 1 and 2. In this case, it's going to be negative 2 and 1. So we can factor it into those two binomials. And we're done factoring. We can't factor this anymore. So now we just have to plot it on the graph, right? We have 3 points. Where should I plot these points?
0, 2, and negative 1.
0, 2, and negative 1. Right, because 5x, 5x is gonna equal 0. X minus 2 is gonna equal 2, and x plus 1 is gonna equal negative 1. So we plot these 3 points onto this graph. Good job. Let's move on to the next section, where it talks about positive and negative intervals. Just erase this. Positive and negative intervals. Our first question is f of x is given as x minus 2, x plus 4, x plus 5, x minus 1, and x minus 9. Wow, that's super long. And our question is, what is the sign between negative 4 and 1? So if we graph this, whatever it is, what's the sign between this area? 이건 지원이가 해볼래?
I wasn't like really sure how to solve this.
Okay. Was anybody able to solve this?
Is the answer like positive or negative? Just like
Yeah, it's just
I got
positive.
positive.
Positive, okay. Positive. There's one answer. Anybody else? Did everybody else who solved it get positive? Or did some other people get negative?
Can it be positive and negative?
It can be positive and negative. It can. Okay, let's try this one together, okay? So see, we have 5 terms here. So if we multiply this all out, what is our greatest term going to be? X to the 5th, right? Well, x to the 5th. Remember what an odd number looks like? Does anybody recall what polynomial with an odd number in its exponent looks like?
Scribbly line thing. From the left
Scribbly
bottom
line things.
to the
Yeah,
right,
right.
top.
To the left bottom to the right top. Something like this, right? And we know that there's five points. So 5 solutions. So if it starts here and it ends here, there's 5 points. 1, 2, 3, 4, 5. Any 5 random points. We know that if we look at the points, which is -5, -4, 1, 2, 9, from lowest to greatest. This is -5, this is -4, this is 1, this is 2, and this is 9. You know that from -4 to 1, which is here, it's below the graph, right? Everyone can see that, right? It's below the graph. So our answer should be negative. Sometimes it's going to ask for the interval, like for say -4 to 2. Then it's both negative and positive, right? It's negative between -4 to 1 and positive between 1 to 2. So sometimes it can be both negative and positive, but in this case, it only asked from -4 to 1, which is just negative.
Oh, I thought it was positive because in the answer it said x equals 5.
Oh, wait, in the answer, it said
The
x
question.
equals 5. Oh, it does. Yeah, it should be negative. Okay, that's my bad. Yeah.
And just one more. On the last question for positive and negative, it's 6 and not -6. Wait.
Oh,
It's -6, yeah.
Yeah, it's -6, not +6. You're right. I'm sorry. I have to make all these problems. So if I make a typo, I'm really sorry. I do it like fast. So yeah. So I guess if you got positive, you're right, because the solution said +5, not -5. So, but does that make sense to everyone? How we got that?
Yep.
Okay, let's do the next question. F of x equals x times x plus 3, x plus 1, x minus 4. That's our function, and we're asked what is the sign between -1 and 4. 살리나, 이거 뭐 넣었어?
I think it's positive and negative.
Positive and negative. Okay, positive and negative. Did everybody get the same answer? Or wait, who was able to solve this section? Because it
I
seems
got
like
positive.
You got positive? Okay. Positive.
I think it's both too.
You think
Wait.
it's both two? So 2
Yeah.
votes for both and 1 vote for positive. Let's try this out. So what's our highest term going to be in this equation? X to the, what do you think? 4th, right?
Power. Yeah.
4 terms. So our highest is going to be x to the 4th. And what does an even number look like? A positive even number.
A U.
A U, a smiley face, right? It's going to look something like this. And we know there are 4 solutions here. So, and our 4 solutions are going to be what? 0? Wait, let's start from -3, -1, 0 here, and 4. So it's the start in the top. Do a wave thing, go back up. Kind of doesn't look like a U, but our end behavior is the same. And we're asked, what is it between -1 and 4? -1 is right here, 4 is right here, and you guys are right. There's a positive section here and a negative section here. Does everyone see that? So both is correct. The answer should be both positive and negative. Let's do one more and move on. Yeah, let's just do one more. F of x is given as 5x plus 3, x minus 2, 3x plus 7. Oh, this one's a tricky one. X plus 5. Yeah. And we're asked, what is the sign between -7/3 and -3/5? 이건 데이비드가 해볼래? 데이비드. 데이비드 이거 풀었어? 아니면 못 풀었나? I guess he didn't solve it. Okay. Was anyone able to solve this one? This one's a tricky one. So
Yeah, I got positive.
positive. Okay. Positive is one answer. Let's try this one. So our highest term is going to be x to the 4th. More specifically, it's going to be 15x to the 4th because we see there's a 3 and a 5 here, but we're just looking at the x to the 4th. And we know that the coefficient is positive. And we said that x to the 4th looks like a smiley face. So it's going to start here and end here. Let's look at our zeros. Our zeros are going to be -5, -7/3, -3/5, and 2. So -5 somewhere here, -7/3 somewhere, -3/5 somewhere here, and 2 is somewhere here. So it's going to do this, 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 and go back up. And what is it between this point and this point? That tiny little thing is going to be positive. Positive is correct. Let's move on. Does everybody get this section? Or is anyone still confused?
I understood now.
Okay, that's good. Let's do zeros of polynomials where we have more than one solution for a single solution. Multiplicity. Our graph looks something like, if I can draw this well, something like this, right? Where this is -2, that's 0, and that's 2.5. And we have 4 answer choices, A, B, C, or D. And Yeji, what did you get?
I'm not sure, but is it B? I
B?
don't know.
B says x, 2x minus 5, x plus 2 squared. Why did you pick B? Was it a guess or?
Because like, oh wait, oops. Because I think it actually, I don't know. I just thought that it would be B.
Well, B is a pretty common, it's a good guess, B or C. Those are 2 good guesses if you don't know. Does anyone else have a different answer? B is one option.
I got A.
A, okay. A is P of x is x squared and 2x minus 5 and x plus 2. Well, let's look at the graph. You see here, it goes through -2, it bounces at 0, and it goes through 2.5. What does that tell us? That means that at x equals 0, there's 2 solutions, x equals 0 and x equals 0. Repeat. So our equation should show this same thing. If we look at our equation, what repeats? Well, x squared repeats. X, which means that in this equation, our solutions are going to repeat. 5/2 and -2. Notice how 0 repeats, but 5/2 and -2 don't repeat, because in the graph, it just goes through it once. So A is correct. In B, x plus 2 is shown to repeat, so it should bounce on this point. But we see that it just goes through, so the answer is A. Does that make sense? Or did that not justify anything?
I think I get it a bit.
You get it? Okay. That's good. Then the next problem. Oh wow. This is a okay. That's 2. That's -1. And that's what? -3, right? Okay. 하늘아, 이거 풀었어?
I got D.
D is x plus 3 squared, x minus 2 squared, and x plus. This is right, I think. Yeah, this is right. X plus 3 repeats, so it bounces here. X minus 2 repeats, so it bounces here. And x plus 1 doesn't repeat, so it just goes through. So D is correct. Let's just move on to the next section of the homework, since we're kind of running out of time. End behavior. So what is the end behavior, right? P of x is -9x to the 9th, or plus 6x minus 3x cubed plus 1. 이건 민혁이가 해보자. What is the end behavior of this graph?
이거 인피니티브 해가지고 하는 거예요?
맞아.
답이? 그럼 막
그치.
SX 하고 인피니티브 이렇게 나와야 돼요?
내가 적는 대로. 이걸 찾아야 되지.
그 P of X S8 SX infinitive P of X is negative infinity.
Negative infinity. Okay.
As x is negative infinitive,
Mhm.
p of x is infinitive.
Infinity. Okay. So he gave as x approaches infinity, p of x is approaches negative infinity, and as x approaches negative infinity, p of x approaches infinity. Did everybody else get this?
I got the same.
Okay, nice. Okay, then let's just move on, I guess. The next section, the next question is p of x. Oh no. P of x is 3x to the fourth minus 5x cubed minus 2x squared plus x minus 18. 시우야 이거 풀었어?
이거 설명해 주세요.
설명해줘. 알았어. Okay. So, how do we do this? Well, we're just looking at the first term where it says 3x to the fourth. We're only really interested in the x to the fourth, right? And x to the fourth is gonna be a smiley face. Remember? It's an even number, so it's a smiley face. And if we look at the coefficient now, is it positive or is it negative? It's positive. So it's just gonna look like this. So let's look at the graph now. As x approaches infinity, p of x also goes infinity. It goes up and up and up. So it goes to infinity. And as x approaches negative infinity, p of x goes to infinity. It goes up and up again. So, yes, so p of x goes to infinity as x goes to infinity or negative infinity. It goes both ways, infinity, yeah. Okay, let's, 이해됐어, 시우야?
네.
Okay, 다행이다. Let's go on with our lesson for today. We're gonna do radicals. Radicals. Has anyone heard of radicals? Rational exponents. You can also call them rational exponents. Okay, let's try it out. So, for example, let's look at this example. Square root of x, right? Radical of x. We're all accustomed to this form where we square root it, right? But there's actually another way to write this where we can write it as a fraction. So x to the half power. I'll explain why. So this is the same thing as this. It's the same thing as this. We just don't write the two because it's unnecessary. Since, for example, if this is the question, x squared, it's asking what times what is x, right? X squared, what times what is x squared? Two terms, so it's unnecessary. We just write this. It's the same meaning, what times what is x squared? In this case, it's just x, but what if there's a 3 there? And let's say it's x. Then the meaning changes. The meaning is what times what equals x. So what? So something times something times something equals x. Whereas in this case, it's something times something is x, or x squared in this case. So this number is actually very important, and we can change it to 4 or 5 or any number we want. But this, I'll show you how this relates to this fraction. So when we write a radical, this is our base. These are our three basic things. A, B, and C. This is our main number. And we can rewrite this form as B of C over A. It's the same thing. In this case, X is to the first power. So number 1 just goes to C. And there's an invisible 2, right? We don't write the 2. So 2 goes to the denominator and the base stays the same. Does that make sense? This is the main form.
Yes.
So if I give you an example, let's say 4 and C to the 8th. You see in this example, 8 is our exponent and 4 is the thingy here, whatever we call it. I don't know what we call it, but C stays the same. We can rewrite this as our numerator and this as our denominator, or we can just simplify as C squared. So this complicated expression can be rewritten as C squared. Pretty simple, right? We can also do it the opposite way around. If we're given X equals 3 to the 8th, and we want to write it in this form, what do you think this is? Well,
8 on the outside.
8 on the outside, right? X goes on the inside the same, and it's X cubed. If we rewrite it, it goes in this form. Okay, so now that we got that down, how can we use this? Properties of exponents. We can use it to simplify very complicated exponents. Who knows some properties of exponents? Let's go over a few. What happens if we, let's give this as x over half, that's x over half, and x over 3 over 4, let's say. X over x to the half times x to the 3 over 4. This is an example of a property of exponent. Does anyone know how to simplify this or solve this? Nobody? Okay. Well, if x is to the something, it's the same thing, then this is the same thing as a plus b. Okay? So if x to the a times x to the b, and we want to simplify this into one term, we can add the exponents. So in this case, half plus 3/4 is gonna be 5 to the 5th, right? So we can rewrite this as x to the 5 to the 4th. That's how we simplify this. This is just adding exponents. But what if we have, or say, a, let's use a this time, 3 to the 8th, and a over 1 to the 8th. How would we do this? Well, it's the same thing. If we have one term here, and it's over this another term, then next, a minus b. When we're dividing and not multiplying, we can subtract the exponents. So what is 3/8 minus 1/8? That's just gonna be a to the 1/4, right? 2/8 becomes 1/4. So we can rewrite this as a to the 1/4. Does that make sense so far?
Yes.
Yes.
Okay, so we covered two properties of exponents. And one other important property, I think that's important. Hopefully you guys know this. What if it's like this? Does anyone know what to do? So we have a base here, an exponent here, and we're multiplying another exponent onto it. Not another term, but another exponent. In this case, we multiply the exponents. Multiply. That's a multiplication symbol. So it's a times 3 over 2. That's it. I think this is the easiest property to remember. And now we can, once we memorized those 3 properties, we can hopefully simplify some hard, what do you call these? Expressions, yeah. So what if you're told to simplify this? That's a 4. This 4. So 3 times 4 square root of z times 3 times z to the 3/4. So our first step when we approach these types of expressions is, see here, we have one type of z in fraction form, but here we have it in radical form. So we don't want it to be in 2 different types of forms. We either want it to be all in fraction form or all in radical form. Usually it's easier to work with fraction form. So I advise you to just change everything to fraction form. So this is already in fraction form. Let's just change this for z, right? What is this z? Can anyone tell me what the fraction form of this is? Nobody?
1/4.
1/4, correct, remember? So there's an invisible 1 here. We don't really write the 1, and 4 goes to the denominator, and the numerator is 1. So z to the 1/4. This is equivalent. So if we rewrite this expression, we can write this as 3 times z to the 1/4 times 3 times z to the 3/4. So everything is multiplying here. So in this case, 3 to 3, we can just rewrite that as 9. And we're left with this. Remember this? We just did this a couple minutes ago. Z to the 1/4 times z to the 3/4. What can we do with that? How can we simplify that?
Add them at the exponents.
Yeah, you can add the exponents, right? Since they're multiplying together, we can add the exponents. It's 1/4 here, 3/4 here, which equals 2. So our answer is just going to be 9z squared, since it's to the 2nd power. And that's it. We're just done with simplifying. Let's do one more complicated example. C over c to the 1/3. Okay, so this looks pretty complicated. So we have a huge radical, and inside of it, there's a fraction and another fraction form radical. So in this case, we have this as a radical form, but we have this inside as a fraction form. Remember I said it's easier to work as fractions. So let's change this whole inner thing into a fraction. Can we change this in 1? What do you think the fraction form of this whole thing would be? This might be a little hard, so I'll just give you the answer. We can just think of this as one term and just see 1/3 and have it, right? We're not really changing this in the inside. So we can leave that, and since the 2 goes out, the 2 goes out to the denominator. This is to the 1st power if you look at it as a fraction. And so the 1 goes out up here, and this doesn't change. And let's try simplifying even further. So what is z? Z is the same thing as z to the 1st power, right? And let's use our subtraction property. See, when something divides, what can we do? Remember? Minus, right? You can subtract the exponents. So z to the first minus 1/3. You can do that, right? You're dividing. So it's going to be z to the 2/3. Okay, we simplified it a little bit more. Let's rewrite that. Z to the 2/3 to the half. And this is our final property. What can we do when an exponent is multiplying? Or like, yeah, multiplying with another exponent. Well, we just multiply, right? 2/3 to half is gonna be 2 to the 6th, which is the same thing as 1/3. It's a bit complicated, but if you take it step by step, I think you guys can solve it. Does that make sense? Did anybody get lost anywhere? Wow, so nobody got lost. Nice. Let's move on to evaluating radical expressions. Radical expressions. So these are harder, I think. But now we're gonna work with numbers, not variables. We always work with z or x or a, but let's work with numbers this time. So 243 to the 7 to the 10th power, 243, 1/10. So what can we do here? We want, as our answer, we just want a clean number. We don't want any exponents. So, well, our very first step, from what I can see, is we can add the exponents, right? We have the same base, and they're multiplying together. So we can add the exponents. So it's 8/10, which is the same thing as 4/5, right? Okay, so how can we make this any simpler? How can we make this a clean number? Well, this is in fraction form. When we make it a clean number, we're accustomed to it being in radical form, right? So let's change it to this type of form. 243 is going to go on the inside, and 5 is going to go on the outside. 4 is going to go inside like that. That's not really any helpful, right? 243 to the 4th power isn't something we can do easily. At least I can't do it easily. So what else can we do? Well, in this case, we can actually ignore the 4 and do this first. So what times what times what times what times what? That's 5, right? Equals 243. So in other words, x to the 5th is going to be 243. And we're just solving for x, right? Well, that's a bit simpler. I think 3 times 3 times 3 times 3 times 3 is going to be 243. This is a hard example. So I think, yeah, this is right. So our answer is going to be 3. So we can simplify this part to 3. And remember, we'll have the 4th power. And this is a lot easier to work with. 3 to the 4th power is going to be 81. And 81 is going to be your answer. So this is hard to find what number 243 is, like what times what times what times what times what is going to be 243. So I'm going to allow you to use a calculator to solve like these portions, since it's not something you should really memorize. I don't think you should ever memorize something that difficult. I don't know why I know that, but yeah. So does that make sense to everyone, how I got 81?
Yes.
Okay, hopefully that wasn't too hard. Let's try one more problem actually, with numbers, just numbers. Let's try 4 1/3, 4/48. Okay. Let's see this problem. So looking at this problem, we're working with radicals. When we simplify, we want to write it into fractions. So let's change that to fractions. We can rewrite this as 1/4. 48 we can rewrite as 1/4 as well. But I think we can simplify the 48 a little further. So, wait, yeah. 48 is the same thing as, wait, I'm lost. Sorry guys, I'm kind of lost too. You know what? No, we don't simplify the 48. Let's simplify this first. We can rewrite this as, yeah. Oh yeah, okay, I know why I'm lost. So this is a property I didn't explain. So usually when you have the same base, so a times b and a times c, we can add the exponents. But if we have the same exponents, so in this case, wait, no, that's not right. If we have the same exponents, then we can multiply the base. So it's the same, like that. So in this case, we can multiply 1/3 and 48. And we can change that to be all over 1/4. 1/3 times 48 is gonna be 16. 16 to the 1/4 is much easier to work with. We can rewrite this as this. And this is just gonna be 2. We can do this because if we work opposite, remember that we said an exponent would multiply with everything. So let's give an example, 3x times y. Remember that we said that the exponent would multiply with the exponents inside? Well, it's in the same case here. 3 can multiply with x and 2 can multiply with y. So this is gonna be 3x squared and y squared. Well, 9x squared since it's 3 to 1. So yeah. So 2 will multiply with everything. We're just doing the opposite thing here. Instead of multiplying out, we're taking it out. So we're taking the 1/4 out, taking the 1/4 out, kind of like factoring. And we're just leaving factoring out the exponent, sort of. Let's do one more example. No, let's do rewriting evaluating expressions. Is anybody lost on properties so far? On exponents? This is a hard topic, so. Can I move on?
Yeah.
Or are you guys totally lost? Okay, let's move on then. Okay, so what if we're given a question? We're told to find a. What is a when 4x plus 3 minus 4 to the x? And we want to find a where a is 4 to the x. So when we rewrite this, it's going to look like this, but we don't know what a is. Well, x plus 3. Well, this is familiar, right? Remember in our adding property, we said that something times something. When we have the same base, we can add it Well, it looks like we have an addition here. So can we work the opposite way around? I think we can. So can we write this as 4x and 4/3 as 4x? This is much easier to work with, right? So we went the opposite way around this time, and we rewrote it as 2 terms instead of usually going this way. So we can rewrite this as 2 terms, and 4⁵ is going to be 64. So we can rewrite this as 64 times 4x minus 4x. So here we're not done. We still want it as 1 term here since it's a times something. So we want to simplify this to 1 term. Well, how can we do that? This is just going to be like any other variable, right? For example, 3x minus x. What do we do? Well, there's 3 of x's here and just -1 of x here. And since there's 3 here and -1 here, we say 3 minus 1, right? Isn't this the same thing here? There's 64 of this and -1 of this. So 64 minus 1 is going to be 63. So we can write this as 63 to 4x. And we see that 63 is the same thing as a then. Anyone lost? Or can I move on? Kind of lost.
A little, yeah.
Okay. When we simplify variables, we say, let's simplify 5x minus 2x as an example. There's 5 x's and -2 x's, right? So 5 of x, 5, it's the same thing as like there's 5 cats and there's -2 cats here. So we can simplify 5 minus 2 as 3. We look at this the same way. 4x is going to be another variable. So we can say there's 64 4x's and -1 4x's because these are the same variables. So 64 minus 1 is just, you can simplify it as 63 times 4x. If we rewrite this, it's the same problem. This and this is the same thing, except this x looks more complicated since it's 4 to the x and not just x. Is anyone still lost on how I simplified that? Everybody gets it now? Okay, cool. Let's move on. Let me just erase this really quick. Let's move on to solving exponential equations. We have 4 minutes left. Let's speed this up. 7x minus 8. Before I solve this problem with you guys, does anybody know what 5 to the 0th power is?
1.
1, right? So let's look at the 5 to the 1th power is just 5. 5 to the 2nd is 25. 5 to the 3rd is 125. But if we go the opposite round, see it's multiplied by 5 every day. If it's the opposite way around, it has to be multiplying by 5 as well, right? So if we want to go the opposite way around, we divide by 5. So this should be 1, which is why if I rewrite this here, 5 to the negative 1, 5 to the negative 2. If we still go that way, we're dividing by 5 again. We divide by 5 again. We see here that 5 to the 0th is 1. So knowing that property, I think we can solve this. 64 7x minus 8 equals 1. How do you guys think we should solve this? What do you think our hint is? What tool can we use? Nobody knows? Okay. Well, we said that something to the 0th power is going to be 1. That's our conclusion, right? Anything to the 0th power. So in this case, if we set 64 to the 0th power, shouldn't that equal 1, right? In the same way, 5 to the 0th is 1, 64 to the 0th should be 1. Okay, so that's helpful because we know that for this to be 1, our exponent has to equal 0. So we can set that equal to 0. This has to be 0 for it to be 1. Because if we plug in 0 here, we know that this is 1. So this is much more helpful. We can just solve for x then. At what value of x does this exponent equal 0? We move 8 to the other side, and we just divide by 7. 8 over 7. So we solved for x. When x equals 8 over 7, this whole equation equals 1. Make sense? Or still lost? Not still lost. Or are you guys lost?
Makes sense.
Make sense?
Mm.
Okay. I'm gonna do one more problem and then wrap it up. Let's do a bit of a tricky problem. 81x plus 5 over 3, 7x plus 2 equals 3, x minus 2. Wow, this looks pretty complicated. So, how should we approach this? Our first step, so 81. I guess you guys have to sort of memorize these. But 81 is the same thing as 3 to the 4th. Like, if you guys don't know that, like, it's gonna get to you as you do these problems. Like, simple thing, it's not simple, but you'll just have to memorize these later. There's really no tip or trick to do it. You just memorize it. 3 to the 4th, we know that 3 times 3 times 3 times 3 is 81. So knowing that 81 is the same thing as this, we can rewrite this. So everything is base 3. So 3 to the 4th, and we're left with the x plus 5 here, right? It's not actually 3 to the 4th. Same thing as 81. We're left with the x plus 5 here. And let's leave the other bases of 3 the same. So now that we have all the bases of 3, it's much easier to work with and simplify. Let's simplify this exponent. Since we're multiplying an exponent by another exponent, we just multiply. So we can rewrite that as 3 to the 4x plus 20, because we have to distribute when we multiply. This is all over 3a, 7x plus 2. And this is going to be 3x minus 2. And what's our next step? Well, this is dividing. And what did we say about dividing? Can subtract, right? Since we have the same base. 4x plus 20 minus this thing. Remember to have your parentheses because your negative distributes. So this is going to simplify to 3, negative 3x, and let's see, positive 18. That should be right. So if we rewrite this whole thing, oh no. If we rewrite this whole thing, it's going to be 3 to the negative 3x plus 18 and is equal to 3x minus 2. Anybody lost so far? Everybody get it up to this point? Really?
Yes.
Okay. So we're left with this 3x minus 2. So let's look at this. How can we simplify this further? So our bases are the same, but our exponents are different. Well, not really different, but isn't, let's say 4 squared 4x. To give an example, x has to be 2 here, right? Because we know that the exponents have to be the same for this equation to be simple. Equal, not simple. Since this has to be the same for this to be same, isn't the same true here? These exponents have to equal the same thing for this whole equation to make sense. In other words, negative 3x plus 18 has to equal x minus 2 for this whole thing to make sense. And we just simplify. We can move negative 3x to the other side, leaving 4x. If we move negative 2 to the other side, we're left with 20. 4x equals 20 divided by 4, and we're left with x equals 5. And that is our answer. Confused or all good? You guys are all good? That made sense?
Yeah.
Okay. Any more questions on this topic? No other questions? Okay, well, that's it for today. I'm sorry if I wasn't so enthusiastic. I'm so tired right now. I have no energy left in me, which is why it might have been a bit boring today. But that's it for today. I'll post the homework on Google Classroom, and you guys are good to go.
Thank you.
Thank you.
Thank you.
Yeah.
Thank you.
Thank you.